Now let's discuss yung concept ng gradient descent. Okay, so basically yung gradient descent is a method para mag-optimize, okay, ng function. Okay. Ang concept ng gradient descent uses mathematical derivative, okay, para malaman kung nasan yung optimum value. Okay. Well, actually, if it's a gradient descent, then you're looking for the minimum value. But if it's a gradient ascent, then you're looking for the maximum value. So sa gradient descent, it generates the negative gradient. Okay? Kasi bumababa siya. Kaya negative kasi binababa niya yung value ng function. Okay? Pero pag gradient ascent, positive yung gradient kasi inaakyat niya yun. Pinapataas niya yung value ng function towards the maximum value. So gradient ascent kasi gusto natin gamitin ito to minimize errors. Okay? So how do we do that? So if we use gradient descent, kailangan pa rin natin ng initial na guess. Yun naman yung ginawa natin before, di ba? So sinabi natin na yung computer will guess kung ano muna yung slope at saka yung y-intercept. Then test niya sa dataset and then ko-compute niya yung error. And then from the error, okay, i-base niya, gagamitin niya yung gradient descent para alamin kung saan direction siya tawag dito mag-change ng ano, kung anong direction yung papalitan niya. Pag sinabi kong direction, what I mean is kung papalitan niyo ba yung slope or kung papalitan niyo yung y-intercept. Okay? By how much pinapapalitan yung slope at saka yung y-intercept will depend on the value of the gradient na makukompute from the method of gradient descent. Okay, so let's see how this is implemented sa dataset natin. So ito is a section, yung nakikita nyo rito is a section of the datasets from 0 to 0.5. Okay? Ito yung ating actual na dataset, yung blue na crosses. And then ito yung best fit line, okay, obtained from linear regression. Okay? Now, yung data na yan, ang values ng data na yan are these. So X data at 0.559, ito yun. Ito yung 0.0505. Okay, at ito yung 0.9551. Okay, so itong mga values na to are these points na nandito. Okay, so in general, siyempre gusto natin i-generalize. So in general, what we do is we assign the X data as X1, X2, X3 hanggang sa X sub n. Then yung Y data as Y1 hanggang sa Y sub n. Okay. Now, anong gagawin natin sa data na yan? So sabi natin, manghuhula tayo at i-compute natin yung error. Okay? So babasa natin yung error from the equation of the line. The equation of the line is y equals b plus mx. Now, if we want to generalize this, magkakaroon tayo papalitan natin yung mga variables na gagamitin natin. Okay? Ano yung mga variables na gagamitin natin? Okay? Ang gagamitin natin variables ngayon ay itong theta naught for the y-intercept at theta 1 for the slope. Okay? Yung y ngayon, tatawagin natin h sub theta of x. H sub theta is a function of x. At ito yung x natin, which is yung independent variable. Okay? Ang tawag natin dito sa equation na ito is our hypothesis. Okay? Bakit siya hypothesis? Kasi nga nanguhula tayo. So, ang gagawin natin is, okay, ito yung initial guess ko. Theta naught is some value and theta 1 is some value. So, my hypothesis is theta 1 is equal to some value and theta 1 is equal to some value. Ipapasok ko ngayon siya dito sa hypothesis na equation and it will generate some value, h sub theta of x. At kukompute ko ngayon yung error. Okay, paano natin kinocompute yung error? Basically, kukompare natin siya with the data set. So kung ito yung una kong hula, yan yung una kong hula, di ba? Diba, theta is 1 and theta naught is 1 and theta 1 is 1. Ito yung line na na-generate from that. May error from that. Ang error is itong blue X mark minus ito. Okay? Kaya ito, h of theta x sub I minus y sub I. Okay, ito yun. Ito yung y sub I natin at ito yung h sub theta x sub I. Okay? Kung gagamitin natin x1, x2, x3, ulitin ko Ito yung y sub 1 at ito yung h sub theta of 1. H sub theta of x sub 1. Ito yung y sub 2. Ito yung h sub theta of y sub 2. So ito, yung x na yan, x mark niyan yan yung y1. Yung y1. At itong line na ito, point sa line na yan ay yung h theta of x1. Ito ngayon, x na yan is y2. Ito is y3. Ito is y4. Y5, and so on and so forth. At dito sa point na ito, okay, kung saan nagko-coincide vertically, yung y2 sa red line, yan yung h theta of x2. Okay, ito naman, yan yung h theta of x3. So yung error ngayon is h theta of x1 minus y1. Okay? Yung error dun sa next is h theta of x2 minus y2. Yung susunod is h sub theta of x3 minus y3. Okay, yan yung error. H sub theta of x1 minus y1, yun yung E1. Okay, and so on and so forth. Pwede natin i-compile lahat ng error na yun. In fact, ang gagawin natin is i-square natin lahat ng errors. So lahat ng errors na yun, i-square natin at i-add natin sila lahat. So sum ng errors. And then i-divide natin by 1 over 2 divided by n. When you divide it by n, kinukuha lang natin yung average ng lahat ng errors. Di ba? And bakit meron kang 1/2 dyan? Well, yung 1/2 lang dyan is something that will be useful later pag in-evaluate natin yung derivative. Kasi nga, kukunin natin yung gradient descent. Di ba? So, it's just a number that we just put there para lang yung gradient will be more convenient to use. So, ang tawag natin ngayon dito sa term na ito is a cost function. And we define it we use the variable j para sa cost function. Now, yung cost function can now be written as this. Okay, saan nang galing ito? Galing yan dito. Kasi remember that the error is given by this. Now, h of theta is given by this. So, replace ko lang ito with this. Okay? And then, yung error, yun na yung pinasok ko dito. Okay. Kaya ito yung h sub theta of x, di ba? At ito yung xi, sorry. At ito yung yi. Okay. Minus. Okay. So by squaring it, hindi na nagmamatter sa atin kung ano yung negative yung difference ng error, kung negative yung error o hindi. Okay, so ito yung ating full expression for the cost function. Now, how do we implement this in code? Okay, to implement this in code, ganito yung gagawin natin. In MATLAB, straightforward na j is equal to 1 over 2 times n times the sum nitong term na ito. Okay, remember na yung theta, yung theta dito inassign ko sa variable na th. So yung theta naught is th0 at yung theta 1 is th1. Yung x ay yung tawag dito yung dataset natin, di ba? So we're summing over all values of x and we're also summing over all values of y. So we're actually summing over the difference between x and y na kung saan yung x ay may coefficient na theta 1. And then meron din tayong tawag dito, additional parameter dito na theta naught. Okay? Now, bago natin isum yan, i-square muna natin ito. So ito, squared, and then sum. And then multiply by this constant. Yung where n is the number of tawag dito, data points. Okay, along the x at saka along the y. So, in MATLAB, ang ginagamit natin dyan, di ba, length. So, length ng x. N is equal to length ng x. Okay, yun yung pag-define natin dyan. So, in MATLAB, since binabago natin yung hula natin for theta naught at theta 1, okay, so we're going to run all values, lahat ng hula natin for theta naught at theta 1, para ma-compute natin yung cost function. So this command generates all possible values of the cost function. And this command, this is in Python, and it does exactly the same thing. Okay, it generates all possible values of the cost function. Okay, now, papansinin nyo, may value yung cost function along the theta naught, at saka may value yung cost function along theta 1. So, ang mag-generate natin ditong plot is a three-dimensional plot. Yung x-axis ay yung theta naught, yung y-axis is yung theta 1, and then of course yung cost function, yun yung z-axis. So, by using this, we're going to plot yung anong tawag dito, yung cost function versus theta naught at saka theta 1. Okay, now sa Python, you can use to indicate yung power, okay, you can use the command power sa numpy na class, or meron din silang double asterisk 2. So pwede rin yun. So pwedeng ito or this term double asterisk, and then yung kung anong power mo siya i-raise to. Okay, so wala na ito pag ginamit mo tong syntax na yan. So now let's take a look at what will happen. Okay, so mamaya natin tignan yung 3D plot. Tignan muna natin yung simple na plot pag isang value lang ng theta naught yung gagamitin natin. So ang sinet ko yung theta naught to 0.5 at yung theta 1 dito yung magbabago. Babaguhin ko tong theta 1, I keep theta 0.5. Theta naught is equal to 0.5. Okay, so ito ay 0.5, ito yung babaguhin natin. And then ipa-plot natin yung cost function versus theta 1. Pag binago ko tong theta 1, ano magiging itsura ng cost function? Okay, so ang mangyayari ganito. Siyempre, ang slope nito is 0. So, 0 yung slope, di ba? Pero yung y-intercept niya is 0.5. Kaya dito may 0.5 ka dyan. Okay, so itong 0.5 na to, hindi yan magbabago. Yan na yung point of rotation ng line na to. Okay, so as in increase, di ba, nagbabago yung slope. Ito yung 0.1 na slope. Ito yung 0.2 na slope, 0.3 na slope. And as we do that, makikita natin na yung cost function na nako-compute using this equation ay bumababa yung value. Diba? So as it comes nearer and nearer to, okay, as the red line becomes nearer and nearer to the data set, okay, bumababa yung value ng cost function. Okay, now, ito yung ideal, di ba? Ang slope is 0.2, okay, at yung y-intercept is 0.5. And makikita nyo na yan yung best fit line that describes all of these data points. And tignan niyo yung cost function. Yung cost function is about, well dito ang sinasabi is cost function is 0. And if we increase further yung cost function, okay, so nilagpasan natin yung 2, makikita natin na tumataas ulit yung value ng cost function. Okay? So, the cost function is a way to describe kung tawag dito, kung gaano kalaki yung error ng hula natin, ng hypothesis, okay, from the data set, okay, from the actual value. Okay? So, yan yung cost function. Now, okay. Okay, now actually, tulad ng sinabi ko nga sa inyo, three-dimensional yung cost function. Three-dimensional siya kasi sa isang axis, andun yung lahat ng possible values ng theta naught. Dito nilagay ko ang theta naught from -2 to 2. Lahat ng possible values ng theta 1. Dito ang nilagay kong value is theta 1. And alam natin, di ba? Alam natin kasi sinet natin na yung m o yung theta 1 is 2. So it should be somewhere here yung optimum value. At 0.5 yung theta naught. So nandito dapat yung optimum value, yung minimum value niya. Okay, so if we run this, okay, makikita natin na, oops, wala nangyari. Okay. Okay, makikita natin na start siya dyan, and then, pag susundan natin yung black dot, okay, kikita natin na as soon as it reaches theta naught equals 0.5 and theta 1 equals 2, na-reach niya na yung minimum value. Doesn't look minimum dito, okay, pero I'm sure pag tinilt natin yung, yung image na to, makikita natin na nasa minimum value siya. And you can do that when you take a look at the code. Okay, and then if I proceed further, increasing yung yung theta 1, okay, makikita natin na yung cost function ay nag-increase. Okay, so this line here is just a section of the all possible ranges of the all possible values of the cost function. Okay, and nandito yung kanyang minimum value. How do we use the gradient descent ngayon? So first we compute for the cost function, okay, which is yung ginawa natin kanina. And then we need to get the derivative of the cost function. Ano yung derivative ng cost function? Ang derivative ng cost function will be based on the parameters theta naught at saka theta 1. Okay? So, kung mathematically, isosolve natin ito by hand, analytically, ibig ko sabihin, we're going to take the derivative of j with respect to theta naught, set it to 0. And then we take, and then solve for theta naught, diba? For the value of theta naught. And then we take the derivative of j, of the cost function with respect to theta 1, and then we set it to 0, and then solve for theta 1. Okay, yun yung ginagawa natin, di ba, by hand. Okay, now, computationally, ganito yung ginagawa natin. So, knowing the equation for the cost function, kunin natin yung derivative ng j with respect to theta naught. Now, this is easily done kasi if we're taking the derivative of theta with respect to theta naught of j, so ang gagawin lang natin is this whole function is a power of 2, di ba? So ibababa natin yung 2 ngayon doon. Okay? Now, naintindihan nyo na yung significance ng 2 dito. Okay, so nawala na yung 1/2 dahil binaba natin yung 2. So meron na lang tayong 1 over n. And of course, itong power na to, i-subtract natin yun from 1 by 1. Kaya ito na lang yung matitira. Since wala namang coefficient yung theta naught, okay, walang coefficient yung theta naught, then ito is just multiplied by 1. Diba? So ito na yung ating derivative ng cost function with respect to theta naught. Okay, what about yung derivative ng j with respect to theta 1? Derivative ng j with respect to theta 1 is ganun din, 2. Ilagay natin dyan. Okay. Tapos, theta 1, may coefficient yung theta 1 na xi. So, ilalabas natin yan. So, i-multiply natin itong buong term na to by xi. Kaya may xi dito. Okay, so ito ngayon yung derivative nung j with respect to theta 1. Okay, now how do we correct for the guess? So, meron tayong unang guess, di ba? Ang unang guess natin is this one. Okay. Na-compute na natin itong gradient descent ngayon o yung gradient ng j with respect to theta naught tsaka theta 1 using this equation. Tapos, isusubtract lang natin itong value na ito from yung initial na guess. Subtract natin itong value na ito from the initial na guess. At magkakaroon tayo ng bagong values ng theta naught at saka theta 1. Okay? At yun yung ipapasok natin ngayon dito. Okay? So, iterative siya na process. Okay, kukompute. Pag napasok natin dyan, solve natin yung error. And then, tignan natin kung tawag dito, kung lumiit. Okay? Pero kung lumiit nga siya, pero hindi pa rin siya ganun kaliit, hindi pa siya minimum value, we again solve for theta, for the gradient along the theta 1, theta naught, tsaka theta 1, and then subtract that from these values, and then we'll get another new set of values for theta naught and theta 1, and then ipasok natin dito to solve for the error. So gagawin niya paulit-ulit hanggang sa makita natin na yung error is minimized. Okay. Now, what is this term here? Ang term na ito is called the learning rate. Narinig nyo na yan kanina. Diba? Dun sa nung inaano natin yung code. Yung machine learning code. Term na yan is called the learning rate. And it will, well, from the phrase itself, learning rate, rate of learning, gano'n siya kabilis matuto. So yung value na ilalagay nyo dyan will depend on how fast the machine or the code will learn about the characteristics of your data. Okay, so crucial yan sa learning ng tawag dito ng dataset ninyo. Okay. So this is how you implement it in MATLAB and Python. Okay. So the derivative of J with respect to theta naught is given by this equation. And the derivative of J with respect to theta 1 is given by this equation. Okay. So ito ay yung cost function na dinescribe na natin kanina. This is in MATLAB. At ito naman yung cost function na dinescribe na rin natin kanina. This is in Python. Okay. Ito yung expression for the gradient descent, for the gradient along theta naught. At ito naman yung expression for the gradient along theta 1. So 1 over n, ito yun. Then theta naught plus theta 1x. Theta naught plus theta 1x minus y. And then isa-sum natin lahat yan. Kaya may sum tayo ng theta naught minus theta 1x minus y. Dito naman, ito naman, theta naught plus theta 1x, ito yun, times x, ayan yan, di ba? Minus y, yun yung minus y, and then multiplied by x. And then isa-sum natin itong buong term na ito. Okay, multiplied by 1 over n. Kaya mayroon tayong sum dito. Okay, so ganun din dito para sa Python. 1 over n times sum nung expression na ito na nasa loob ng square brackets. And then para sa gradient ng cost function with respect to theta 1, theta naught plus theta 1x minus y, ito yun, multiplied by x. Multiplied by x, and then isum natin lahat ng values na yun. And then yung correction is theta naught, ito yung initial values, di ba? Minus yung learning rate times yung gradient with respect to theta. So ito nakuha natin from here. Then yung theta 1 minus yung learning rate times yung gradient with respect to theta 1 will give us new values for theta naught and theta 1. Okay. So ganun din para sa Python. Okay, theta naught minus a times gradient with respect to theta naught. And then theta 1 minus a times gradient with respect to theta 1 will give us new values for theta naught and theta 1. Okay. So ganyan na siya ka simple na i-code. Okay, straightforward. If we do that, okay, ganito yung lalabas. Okay, now, ang ini-introduce ko dito is yung learning rate. Now, here, I've set the learning rate to be 0.2. Okay, now, what will happen to the function with this type of learning rate? Okay, so, play natin to. Okay, so anong napansin ninyo? Kung nakita nyo, okay, una ganyan siya, di ba? Ang initial guess is -2 para sa theta naught at 0 para sa theta 1. Okay. Next guess is 4.6 para sa theta 1 and -0.5 para sa theta naught. Okay? And nakita nyo yung slope o yung line nandun sa kabila. Nakita nyo yung dot nandun din sa kabila. So hindi na cover na nung 3D plot. And then sa next iteration, andyan na siya, lumipat na naman sa kabila itong dot na to at lumipat din yung line dito. Okay? So makikita nyo, nagmo-move yung dot, di ba? Pag ganyan. Okay? May imagine nyo yung cost function. So yung cost function, dahan-dahang bumababa ng ganon. Okay? Nag-jump yung cost. Pero habang nagpo-progress, makikita nyo na paliit na lang yung pag ano niya tawag dito pag vibrate. And yung linya na ito ay papalapit na ng palapit sa optimum value. In fact, kung tignan niyo yung theta 1 nasa 2.08 na siya, 2.09, and yung theta naught is negative 0.44. Of course, this should be positive, di ba? Okay, so yan. So makikita nyo kung paano nagpo-progress yung dot ngayon at kung paano siya lumalapit dun sa optimum na value. Palitan natin yung learning rate niya ng 0.1. Okay, if we do that, tignan yung mangyayari. So, medyo mabilis ang mga pangyayari sa simula, pero ganito yan. Ganito yung nangyari dyan. Ganyan siya na simula, and then sa next iteration, bumaba siya kaagad doon. And then, dahan-dahan na siyang nagsislide nearer to the tawag dito, optimum value. Pansinin nyo rin itong ano to, wag lang itong dot na to, pansinin nyo rin itong theta 1 tsaka theta 1 values na yan. Okay, lumalapit siya to the optimum value. Now, if we change, ayan. So, pag nakita nyo, dahan-dahan siyang di ba? Nagbabago ng slope. Now, if we use a smaller learning rate, okay, mas smooth na yung, niya, yung tawag dito, yung pag-learn niya. Pero tignan nyo, for the same number of iterations, hindi siya umabot. So, yan. So, pag 50 iterations lang, hanggang dyan lang siya. Okay, and if we use an even smaller learning rate, ganyan yung magiging value niya. For 50 iterations, nadudun siya. And ang layo pa niya, di ba? So what does this tell us about the learning rate? Okay, now, ito muna, 0.5 na learning rate. From 0.2 to 0.1 to 0.05 to 0.01, gawin natin 0.5 ngayon. Ano mangyayari dito? Tignan nyo itong y-axis, itong z-axis, cost function. 35 ang value niya ngayon. Tignan nyo mangyayari. Nakita nyo na ang exponent niya na is 10 to the 55. So by using a learning rate na 0.5, hindi siya dumating sa optimum value niya. In fact, nag-diverge siya. So it's really critical to select a good learning rate. A small learning rate, okay, converges to a minimum quite slowly, which means na mas marami kang iterations na gagamitin, which means na more computational time at more computational resources. Large learning rate converges to the minimum faster. Okay? Pero if it's too large, it may not reach convergence and it may diverge altogether. Okay, so, well, ganun din naman sa ganun din naman sa tunay na buhay, di ba? I mean, gusto natin kung gusto talaga nating matuto, we have to learn at our own pace, di ba? Some of you have lower values of learning rates, and some of you have higher values of learning rates. And if I apply, kung yung teacher ninyo applies a high value of learning rate sa inyo at hindi kayo maka-catch up, ano nangyayari? Divergence, right? Okay. So parang ganon yung idea, yung concept. So there is an optimum value for a learning rate. And actually, that optimum value is not exactly the same for each model na ginagawa mo. In fact, you have to really fine-tune the learning rate. Okay, anong tawag dito? Every time na gumagawa ka ng bagong model. So there's no fixed value of a learning rate. It can change, it can vary depende sa model na tawag dito na gusto nyo na ginagamit ninyo.